The Anomalous Behaviour of Water by Hannah Dabke. The anomalous behavior of water is also referred to as the density anomaly, and this concept may shock you. Throughout most of our school careers, we are taught the basic fundamental properties of different substances. The anomalous behavior of water may be something that has been touched on briefly, but when you look deeper into it, the basic laws of how substances behave under certain conditions are tested. The term anomalous is used to describe something that deviates from what is standard, normal, or expected. To better understand this topic, I broke it down into two main categories: hydrogen bonding and the polarity of water. Hydrogen bonding happens when there are large electronegative differences between oxygen and hydrogen atoms, causing their bonds to be opposite. This results in a strong intermolecular attraction between the water molecules. We've all heard the term opposites attract, and in this case, it is very important to how water behaves. The oxygen end of a water molecule is slightly negative, while the hydrogen ends are slightly positive, creating the polar bonds and ultimately the attraction between the two charges. These bonds are responsible for many of water's incredible abilities. Have you ever accidentally filled up a cup with just a little too much water, and instead of spilling over, the water hovered slightly above the rim of the cup? This cool property is due to high surface tension created by the hydrogen bonds at the surface of the water, acting as an invisible skin. Water mounds up when a container is overfilled before it spills over. An insect called water skippers use this to walk on the surface of water. Water has one of the highest heat capacities of all liquids because in order to change 1 gram of water 1 degree Celsius, it takes 1 calorie. This is why oceans are much cooler than land, since it has such a high heat capacity and requires more heat energy to warm up. We all know that most substances will become less dense when heated or in a liquid state, and become denser when cooled down significantly or in a solid state. If this was true for water, icebergs would be completely submerged into the ocean, and ice cubes would sink to the bottom of cups. When water approaches its freezing point, the molecules get closer together and hydrogen bonding creates a hexagonal crystal structure that has a lot of open space. This causes water to float since it has a lower density as a solid than as a liquid. This prevents bodies of water from completely freezing over and aquatic animals and plants from dying during the winter. A big factor in hydrogen bonding is polarity. Polarity is the intermolecular force between the slightly positive charged end of one molecule to the negative end of another or the same molecule. Since there is no net charge to water molecules, polarity creates a slightly negative charge on the oxygen molecule and a slightly positive charge on the hydrogen molecule. Because of this, water molecules attract or are attracted to other polar molecules. They also attract other water molecules due to the opposite charges between them and form hydrogen bonds. Water is a substance that will continue to amaze us as we continue to discover more properties it has and how it is used to maintain life on Earth. This is the end of my presentation. Thank you for listening.